When working with equations, there are three possible solutions that you can get. You can have a unique solution to an equation where there's just one answer. That's your solution. You can have a situation where you have no solutions because it doesn't matter what number you put in there, nothing is going to make it work. And then there's something called the identity, where for every number you put in for the variable, all numbers are going to work. And I'd like to take a look at these three situations. So if we look here at the unique solution situation, I have an equation where 6 plus the quantity 5 squared minus 5 divided by 2 is equal to some variable p. I have to do the order of operations on this equation in order to solve for p and see what my possibilities are. So I got to work from the inside out here, and I've got to evaluate my exponent inside my parenthesis. 5 squared is 25. Then I still have parentheses, and I have to do the operation inside parentheses. So 25 minus 5 is 20 divided by 2. Now I have to work from left to right with multiplication and division. So I'm going to ignore this 6 plus, so I'm just going to write it down. And I'm going to take 20 divided by 2 is 10 equal to p. Now I can do my addition. 16 is equal to p. I'm going to use the symmetric property of equality and turn that around and say p is equal to 16. So the unique solution to this equation is 16. 16 is the only number that will work for p. Now I want to look at a possibility when there's no solution. I have to do a couple more steps here. Again, I'm going to work on the order of operations. So I have to do what's in parentheses first. So I'll do 3 plus 2. That's equal to 5. And I'm going to do the computation inside this parenthesis as well. 10 minus 3 is 7. Now I'm going to do the distributive property here and write this as 5n plus 6 is equal to 5n plus 7. Now if you look at this and try to plug in any number, like if I would plug in 0, for example, for n, I would have 5 times 0 plus 6 is equal to 5 times 0 plus 7. I'm going to let, in this situation, I'm going to let n be equal to 0. So I'll get 0 plus 6 is equal to 0 plus 7, or 6 is equal to 7. Well, this is not true. So this cannot work ever. So this is a no solution situation. There isn't any number. 5, if you look, just look at it, 5n plus 6 is equal to 5n plus 7. That is never going to work. So there's no solution there. The flip side to that is an identity, where every number works. I'm going to scoot this over a little bit. And again, I'm going to do order of operations just for practice. And I'm going to do what's inside parentheses on both sides of my equation. So I can take 2 times 5, which is 10. 3h plus 6. Okay, are there like terms here? No, there are not. So I just have to leave that alone. Over here, working from the inside out, I can combine these two like terms. 2h plus 1h is 3h plus 6, and I have a 2 on the outside here. Over here, I have 10 minus 8, which is 2, times 3h plus 6, equal to 3h plus 6 times 2. Now I could finish this out. I could use the distributive property and say 6h plus 12. I multiplied 2 times 3h plus 2 times 6. And I do the same thing over here. I distribute 2 times 3h is 6h plus 2 times 6, which is 12. And if you notice, I have the same thing on both sides. This is called the identity. They're equal. They're the same thing. Okay? So, recapping. 3 possible situations with an equation and a variable. I can have a unique solution where I just have one answer. I can have no solution. Okay? And we mark that like this. Let's mark this up here. 16 is the solution. Okay? For the unique solution. None. No solution. And then if we want to infinity, every number is going to work in that situation. That's called the identity.